problem number 3310. Remove methods from project. You are maintaining a project that has n methods numbered from 0 to n-1. You are given two integers n and k, and a 2D integer array invocations, where invocations I equals AI BI, indicating that method AI invokes method BI. Okay, I think this is maybe a directed graph. Okay, there is a known bug in method K. Method K, along with any method invoked by it, either directly or indirectly, are considered suspicious, and we aim to remove them. A group of methods can only be removed if no method outside the group invokes any method within it. A group of methods can only be removed if no method outside the group invokes any methods. Return an array. Okay, I think this is like return an array containing all the remaining methods after removing all the suspicious methods. You may return the answer in any order. If it is not possible to remove all the suspicious methods, none should be removed. Okay, so method K together with any method invoked by it, either directly or indirectly, are considered suspicious. So we need to find the group that contains K. A group of methods can only be removed if no method outside the group invokes any methods within it. I think we can, this is kind of confusing. We can change the methods into nodes. So there's a known bug in node K. Yeah, method is a node. And so node K along with any node invoked by it, either directly or indirectly, any method. Method A invokes node A invokes node B. So starting with K, yeah, it's a direct, yeah, it has directions. So every node that is from K are considered suspicious. Yeah, so we need to find a group that starts from K and all the nodes that it can reach, and we need to remove them. And the group of methods can only be removed if no other nodes outside the group. It's like no other so okay, so it can only be removed when see return an array containing all the remaining methods after removing all the suspicious methods. You may return the answer, but to remove all none should be removed. Okay, so that's okay. So first of all, the limitations. So for invocations, can AI equals BI. And also the range of n. Range of k. And the length of invocations. And like in the invocations, can we have repeated edge, like multiple edge between two nodes? Okay, let's first check. So the range, it says n is at least 1. And k is at least 0. So our node is start from 0. Okay, so we have at least 2 nodes. And k is 0. Okay, so k will be, k is the nodes, one of the node, and we can have 0 invocations. That means no edge, so we can have only, since n is 1, at least 1 node, so we can have 0 in, and AI will not be equal to BI. And invocations I will not equal to invocations J. Okay. Then let's start we can check the example. So okay, so that's first, look at the first example. It has 4 nodes and k is 1, so the bug will be starting from node 1. And so node 2, okay, so node 2 is suspicious. These 2 methods are suspicious, so but they are, like, this group is suspicious, but they are invoked by other methods outside the group, so we cannot remove anything. Okay, and let's see example 2. There are 5 nodes. K is 0, so the 0 node is suspicious and it invokes 1 to 2, 0 to 2. 0 to 2, 0 to 1. So node 0. Oh wait. Oh here, node 0. This is suspicious. This is also suspicious. This is also suspicious. So they itself form a group. Then we can remove all the things, since no other nodes will invoke 1, 2, 0. So we can remove this, and the remaining is 3 and 4. Okay, and we have 3 nodes, and node 2 is suspicious, and node 2 is invoked by 1, and okay, 2 and 0 are suspicious. Okay, and since and 1 is suspicious as well, since 2 can go to 0 and can go to 1. So all the things can be removed because no other node will come to this group. Okay, so to remove a group, it has to be all the nodes in the group should be suspicious, and it cannot relate it to other groups. So I am thinking of finding. Okay, the first thing will be using a dictionary to create an adjacency list, so it will be easier for us to see which node is connected. To see the nodes that is connected to each other. So let's start with adjacency list. So it will be like the nodes list. For A, B in invocations, nodes A will append B, since it is a one direction graph. And then we would like to see the condemned, the suspicious nodes that are in the group. Yeah, I think I would use a depth first search and starting from K and try to see and notes. Yeah, I can see. Yeah, if I start with 1, then I can find 2. So 2 is suspicious. But how can I know yeah, the other, like K is actually invoked by other nodes? Yeah, I have K Okay, so yeah, we will need we need to know which node is suspicious, so we need to have a data structure to store it. Okay, so we will have suspicious it would be a set, and we will start our DFS suspicious from K, and yeah, we will first create our method, our DFS, to find the suspicious methods. And okay, so starting from K, and yeah, if we can visit okay, so when enter k, k is in the DFS, then then we can use this adjacency list to see who is connected with k, and then find all the suspicious nodes. So we will use a for loop, and nodes in nodes I, and if suspicious, okay, if not okay, if not suspicious, then we will move to it and check its connected nodes. And when enter the DFS, it will be tagged to suspicious. So like k will enter this function, and it will be added to suspicious, and then we will see check the k connected nodes, and that, for example, one, we have 0, 1, 1 will have 2, and 2, no, we will not have 2, we will have 3, we'll have 2, like this. So for k is 1, then we will for node will be 2, so it is not in the suspicious list set, so we will go into it to check, and 2 will be added to the suspicious node, and as well as k, and then since 2 is an empty array, we will not enter the for loop and return. Yeah, so the suspicious set will be like 1, 2, and and then we have to check if there are other, if other nodes can go to 1 and 2, are connected with 1 and 2. So we can I think we will have another DFS for finding the connected nodes, and we have called DFS I. And then we shall have visited set So when we enter DFS, we will add it to the visited set. So it will be, and then for node in nodes I, if not visited, then if not in. I will say if not in visited for this node. And also if not in visited and if node in suspicious, then we cannot remove k. We cannot, there is other so we cannot remove the k, we will return the whole thing. If not, then not in visited, then we can keep going on. And we will let's say for I in range, I want to for loop the node and see the groups, check the groups, and check if there are nodes that outside the suspicious group invokes the node inside the suspicious group. Then we cannot remove it. Else, we can remove it, the whole group, and return the rest of the nodes. So for I in range n, if I not in visited, let's start DFS I. Not in suspicious. Okay, if this node is not in visited and I is not in, this node is not in suspicious, then we can go find this group and then have its node. I think we can, yeah, we can have remains and have answer. So yeah, if it is not node is not visited, then we can add the node into remains. Yeah, we don't need to pop. So okay, so for example, this should be returned. This should we can have answer here, and yeah, since maybe we have many groups and only one group has k is suspicious, then we should add up the whole thing. So after finding the connected nodes, we should append our remains to answer. So remains, concat. Is there concat for Python? Oh, it will use add. Oh, extend. I'll extend. I think no need, like we can, yeah. But we don't know. Yeah, like we don't know. Yeah, when we finish DFSI, we don't know which condition they enter. maybe we will say, we will have a cannot remove. And if it is, and we will have set this to true. Then after finish the for loop, we will return if cannot remove, else we will return remains. And if cannot remove, then we will return range n. Okay, so that's dry run the first example. So now, we have this adjacency list, and to find the suspicious nodes, we will start from k equals 1, and we will have 1 and 2, and then we will start our, we will have a for loop from range n from 0 to n minus 1, so it will be 0, 1, 2, 3. So for 0, starting from 0, it is not in visited yet, since visited is empty. Okay, so now it's empty, and 0 is not in the suspicious set. So we will run dfs 0. So in dfs 0, we will first add 0 in the visited, and for 0, the connecting node is 1. So does 1 in suspicious? Yes. So we cannot remove is true. We will return. Okay, so we will already return, and then we will move. Okay, this will be true. I think we can have an early stop if we'll break. Then we will break, then we will return the whole thing. Okay, we can try the example 2. We have 5 nodes, and the adjacency list will be, let's see, 0 will have 1, 2, and 1 will be, 1 will be 2, and then 3 will be 4. Okay, so now let's start with k. Set will be empty. Start with k equals 0, so the suspicious will be 0, add 0. And for 0, it has 1 and 2, so it's not in suspicious. So we will go into it. So we will add 1, and let's see, 1 will have 2, and 2 is not in the suspicious set, so we'll add 2 as well. And for 2, 2 has an empty, 2 does not connect it. It does not invoke any node, so then we will return. Then for node, for 0 node, we have, last time we have 1, and now we will have 2, but 2 is already in the suspicious set, so we will return. And okay, so we'll finish the suspicious set, and we will come to check the remaining. So for I in range, for the whole nodes, we have 0 to 4. I will be 0 to 4, and first of all, cannot remove as false. Like this. So we'll start from 0. If 0 not in visited and 0 not in 0 is in suspicion. But we did not. I think, yeah, we cannot like this. Then we did not go into the 0, and we did not set it cannot remove. So maybe but okay, I think we should check if I in suspicious, then we will set connect remove to true, then we'll break. Then if I is not in visited, then we will have dfs I. So for example 2, we will directly run into, we will set connect remove to true, then we will return. Oh no, no, it's not. If I is suspicious, then I think we should wait. If I is suspicious, then we cannot set it to cannot remove because it can remove. So if I am suspicious, we will continue. We should this. Don't need this. And okay, so we will move to okay, so now I is 0, then we will continue, and then it's 2 now, it's 1 now. 1 is also in suspicious, we will continue. 2 is also in suspicious, we will continue. And so then So yeah, if we will have 3, it will have 3 now. I is 3. So if 3 not unvisited, yes, visited is not. Then we will start traverse. So visited will add 3, and for its it will have 4. So 4 is not in the suspicious, so and it is not visited. So we will have remains appended. Oh, we did not append 3. So we will, I think we'll append here. So for remains we will append 3, and then it will be 4, and 4 will be added in the visited. Yeah. Another situation will be I'm thinking of 5 nodes like case 2, but there is another node pointing to 2, so maybe like or maybe 6 nodes, and we have 5 to 2. So if it's the case, then yeah, let's have checked it. So for this, the adjacency list will be 0 will be 1, 2, 1 will be 2, 2 has an empty, 3 will be 4, and 5 will be 2. So let's have it. Yeah, for this we cannot, we should have cannot remove equals true, and then we should return the whole thing, since we cannot remove the bug. So okay, so for suspicious we'll have 0, 1, 2, and then for the let's start with here. So okay, so I will be in so we'll start from 0, and we have 6 nodes, so we'll start from 0, and then 0 is in suspicious, we'll continue to 1 is as well, 2 is as well in the suspicious set, so we'll continue to 3, and then 3 is not in the visited node. So I'm thinking if I should add 2 visited. So now that's 3. So 3 is not in visited node, then we will add 3. So 3, and remains will append 3. And 3 has a connected node, which is 4. So we will dfs 4. We will add it to the visited node, and then visited set, sorry. And we will have the remains at 4. Okay, so now, since lastly we have 3 for I, and we'll have 4 now. So 4 is not in suspicious, but it is in the visited. So we will move on to 5. And for 5, is 5 in suspicious? No, it's not in visited. Yes, so dfs 5, visited will add 5. Then we'll have remains append 5. For node and nodes, 5 has 2. Okay, if 2 is yes, then we will set cannot remove to true, then we will return. So we will return, and yeah, we have finished the for loop as well. So if it's true, then we will return it. Yeah, it seems quite well. Okay, let's check. Oh, case 4. Oh, there. Oh, stupid mistakes. Okay. It's I. Oh. Oh, why? I have set cannot remove to true. True is in suspicious set. Okay, I think this cannot remove has something wrong here. Why this is true and this will print? Yeah. now have false here. Is it? Should I use like non-local? Cannot remove. Okay. Okay.